Hi, my favorite math peeps. This week, what we're looking at is we're continuing on with quadratics. As I said earlier, that's what we're going to be doing for the rest of the year. And there's so much to do with quadratics. And you should have already watched the Desmos activity or done the Desmos activity called Rocket Man and did all the problems in there or went through the activities to have an understanding of what I'm going to do now. That Desmos activity ended with using the zero product property to be able to solve a quadratic function without having to graph it. So what I'm going to go through is how to do that without any graphing. The first thing you need to know is you need to know the intercept form of a quadratic function in order to find the zeros, which we also call the solutions. Also, you need to understand how to use the zero product property. So those are the things we're going to do today. And there's only 4 examples. And these 4 examples should then set you up to do the math space assignment, which you've got to sign in to do. I put the join code on the Google Classroom assignment doc, so you can get there. And if you have any problems, please let me know. So we have 4 quadratic functions here. To review what a function is, a function relates one variable to another. In this case, y is going to be equal to whatever the x value is when you plug it into these expressions. In order to make it an equation that we solve algebraically, we've got to remember that the zeros of a quadratic function is always when y equals 0. Because by definition, they are the x-intercepts. So the first step is set y equal to 0. So set y equal to 0, or say substitute 0 for y. Either way works. Now, the zero product property is one thing that I tried to get you guys to at least understand in the Desmos activity. But if you didn't, let's just think about it. Right now, I know x is a wannabe number. It's a variable. It will be a number eventually. And when I have a number for x, this whole parenthesis will turn into a number. So I have one number multiplied by another number. Again, that x will become a number, and I'll be able to do the math, and I'll get a parenthesis. Here's what the zero product property says. The zero product property says any number multiplied times 0 is going to be 0. I just picked a random number. So that means either x plus 3, we want it to end up being 0, or x minus 4. I want whatever is contained in the parenthesis. When I'm done substituting x in there, I want this whole thing then to evaluate to 0. So I'm just going to solve for that. If I want to know what value does x need to be in order for this first parenthesis to be 0, I'm going to solve. So I'm going to say minus 3. And then from there, we simplify. X equals negative 3. That's one of my zeros. Or let's solve this one. Add 4. I don't know why I put that parenthesis there. Add 4. But it's kind of bugging me. Oh well. X equals 4. We added 4 to both sides because remember we do the opposites. This is a minus 4, so you subtract 4, that goes to 0. To keep it an equation, if I added 4 to this side of the equal sign, I have to add 4 to the second. So 0 plus 4 is 4. Okay, so I have 2 answers. And if you remembered on the graph of the quadratic, there were 2, in this case, there were 2 intercepts. So, but I want to check. And if you check your solutions, you've got to check it twice into the original equation. So the first check you're going to get is checking when x equals 3. Let's do that first. So you take your original equation, 0 equals, this is an equation, but we started with a function. And the difference is that it's a y equals, so it relates an x and a y. This is an equation because it's just 0 equals. So 0 equals x plus 3 times x minus 4. What did we say we were substituting in? Anyone? 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 Well, this first one we said let's substitute x equals -3. You guys better be careful. I'm going to start calling on you, and I expect you to answer. Haha. 0 equals, instead of x, what are we putting in? Good job, -3. Instead of x here, again, -3. So let's see what works. 0 equals, what's -3 plus 3? They are opposites, and what happens to opposites? They add to 0. Then we have -3 times -4, and that's -7. So remember, the zero product property says if you have two numbers multiplied together and one of those numbers are 0, the answer is 0. So I proved out that x equals -3 is one answer. But in this case, we have two answers. And if you remember right, the second, we would have had two x-intercepts. I didn't know that you couldn't see this. Now you can. So we know that this is going to intercept. If you were to type this equation into Desmos, you will find that it has two x-intercepts or two zeros. So now let's say check that x equals +4. We have to check twice because we have two answers. So 0 equals x plus 3 is the same equation, and x minus 4. Substitute, what number? Substitute 4. Well, we've been in distance learning too long. I'm kind of going crazy. I don't know about you guys, but this is kind of difficult. Okay, so instead of x, we substituted 4 because that's what we're checking. Now we simplify. Remember, parentheses first. So 4 plus 3 is 7. Parentheses again. 4 minus 4 is 0. So again, 0 equals 0. Did it work? Yes. So our two answers are x equals -3 or x equals -4. Hopefully you guys are taking notes on this. If you're not, that's fine, but it may help when you get to the math space activity that I do expect you to do. So this is our starting function. It's a function because it's a y equals based on x. To set up the equation, you have to get the equation, y is 0. So we're going to substitute 0 equals x plus 11 and x plus 1. Now we said this is solving algebraically. Algebraically is because we're using the principles of algebra. The other way we could solve it is we could actually put in y equals x plus, we could put in the function into Desmos and find the answers. In fact, one of the extra credit opportunities I am going to let you have this week is for you to do just that, and then you would share your answers with me. But that will be on the assignment list. That's a little bit better. Okay, so I need to find out what x's are. There's two of them. So we use, again, the zero product property. Now, I didn't say that on the first one, but I'll say it here. Use zero product property. This is like at school. I'm having the same problems keeping it on the screen, but I don't have you guys say, move it over, Mrs. Shrillo, or motion this way, Miss Shrillo, no, that way, Miss Shrillo, up a little, Miss Shrillo, down. Anyway, let's go on. Either x plus 11 has to equal 0 or x plus 1 equals 0. Those are our only two options, and we will have two values. We're trying to figure out what is the x value that would make the first binomial evaluate to 0 or the second. So in this case, you're going to subtract 11, and then that is x equals -11. Or you're going to subtract 1, and that is x equals -1. And the reason I'm checking is because I don't think that you need help in how to do it, I checked to prove to you the zero product property. The check actually shows you what the zero product property is. So the first check we're going to do is when x equals negative 11. We use our equation, not our function. X plus 11 and x plus 1. And first thing you do is you're going to substitute negative 11 in for x. So you have 0 equals negative 11 plus 11 times negative 11 plus 1. Now the zero product property says only one of these numbers, after we substitute the x in, has to go to 0. So negative 11 plus 11 are opposites. That does equal 0. Hey, I'm done. I'm free and clear if I did everything right. Even if I made a mistake in the adding of this, negative 11 plus 1 is negative 10. Even if I made a mistake, it wouldn't matter. No, because we have this 0 here. 0 times anything is 0. And so this check actually shows you the zero product property in real numbers, which is easier to understand than saying either this has to equal 0 or that has to equal 0. That's pretty hard, Miss Shirley. How do you do that? Well, let's see if we can do this check to make sure that negative 1 also works. So start with your equation. Substitute. What are we substituting this time? We are substituting negative 1 in for both x's because we want to check that negative 1. When we say check, we're seeing to see if by the time we get done with all the math, after you make that substitution, you get an equation that is true. This equation is true. 0 does equal 0. This equation is true. 0 does equal 0. This equation is also true for the same reason. Now, if it was 0 equals some number, okay, either you did your math wrong up here or you did your math wrong in here because this has to come down to 0 equals 0. So again, we're going to substitute in negative 1. That's the other reason I like to use colors. With all this black on the paper, I have a hard time seeing where I've left off because, you know, I go on my little tangents. Okay, so we substitute negative 1. Now let's do the math. Negative 1 times 11 is a positive 10. Hopefully this turns into 0 because if it doesn't, we've done something wrong. But guess what? Negative 1 plus positive 1 is also 0. So 0 equals 0. That also works. So x also equals negative 1. Now in the Desmos activity, one of the questions was, I think I asked something about explain it or what do you notice? The pattern that you notice. And the pattern that hopefully you noticed was that the solutions are always opposites of the constant in the binomial. X plus 11 is a binomial. The opposite of 11 is negative 11. Remember, opposites add over here. Opposites add to 0. So here, negative 11 plus 11 was 0. Over here, the opposite of positive 1 is a negative 1. Because when I add opposites together, I get 0. So the pattern is your solutions are always opposites of the constant number that's in your original binomial. Now we have 2 more. And the extra credit opportunity is going to be for you to graph these 4 problems, and I will write it down in my assignments list for you to graph these and prove out that we really did do it correctly. Okay, so we start off with our function. And we want to come up with the equation. And we do that by setting y to 0. And I'm probably not going to explain as much, but I will write it down because I just can't help myself. Because remember, the zeros are called zeros because they're on the x-axis. Every single 100%, all of the points on the x-axis has a y value of 0. And that is one of the reasons we can use the zero product property. You cannot solve any equation if you have more than one variable. The original function has 2 variables, an x and a y. The way we wrote it into a one variable equation was substituting 0 for y, so now we can do it. So now we're going to use the zero product property. Ah, another mistake. Okay, so that means you set what does x need to be for x minus 7 to go to 0. Algebraically, this is how we do it. After you do enough of these, you're going to be able to guess immediately what the solution is. And at that point, you don't have to show me any of the work. But in this case, I don't know that you're there yet. So we're going to prove it out the long way. And proving it out doesn't hurt. Proving it out just means when you forget it next year, I don't know that you'll ever keep these notes, but guess what? They're all online now. If you forget it next year, you have something to look back on. So here x equals 7. Again, I'm not going to explain all these steps because they're the same steps we used in number 1 and 2. So those are your two answers. You can check it. X equals 7. Check. X equals 8. Squiggly line because it's just prettier. Okay, so we're going to check this. 0 equals x minus 7 and x minus 8. 0 equals, substitute 7 in for the x. Okay, I can't help myself. I wasn't going to do it, but I'm going to do it anyway because I just have to. It's one of my compulsions. So 0 equals 7 minus 7. Oh my goodness, there's our 0. In fact, I think I'm going to go through and I'm going to highlight all the zeros just to point out the fact that one of the factors that we're multiplying together is 0, and that's why the zero property works. Zero product property. Wow, I think it's been a long day. How about you guys? You have a good day? My time right now is Friday, May 8th. So here we want to substitute in 8 for x. So you have 8 minus 7. And 8 minus 8, oh my goodness, do you see the 0? Do you see the 0? Do you see the 0? I see the 0. I'm so excited because I'm going so fast because I'm done. It makes me smile. And this one, guess what? I have to do because I made it look a little different. You're saying, well, this isn't two binomials. This is a binomial raised to the power of 2. Aha! But what is that truly? X minus 2 squared, guess what that becomes? And what do you have? You have a binomial. Now, that is our original function. We're going to make an equation. You should know how by now. That means setting y equal to 0. And use the zero product property. What do you notice about those two? If you said they're the same, you're perfectly correct. So guess what? Once they're the same, I really don't need to do it twice. I only need to solve one. Because there's only one 0. Now, if you reviewed the work from last week, and it'll be on this next, the May 11th assignments, it'll say review of May 8th. There's a portion in there that talks about how many zeros a quadratic can have. So to be clear, this one had one solution, but all the others had 2 solutions. You can even, if you go back and review that video, you can even have no solutions, which I will deal with another time, just not today. And down at the bottom here, I just want to summarize how you solve quadratic function in intercept form. Intercept form is when it looks like the product of two binomials. This is intercept form with all the, with just letters. Okay, that's intercept form. It's the same thing as factored form. Okay, what you do is you substitute the y value with 0 to set up the equation. Then you use the zero product property to define the solutions, and then you check both solutions. If there's both, check both or one solution. Oh, guess what? I forgot to check the solution. Aren't you glad I went through this? Let's go back. I forgot to check. Let's check this one. Check x equals 2. And let's pray that it works. We go into the original one. Whenever you check, you go into your original equation, not the expanded one. 2 minus 2. Oh my goodness. Gosh, life is so great right now. What's 0 squared? What 2 minus 2 is 0. What's 0 squared? It is 0, and it works. So your answer is, ta-da, x equals 2, and I think I'm done. Any questions? If you have questions, you know how to get a hold of me. This is kind of what you're going to be doing on the math space, which is your last activity, not unless you want to do extra credit. The math space requires you to join. I put the link in there to join. And one of the questions is kind of difficult. So even though there's only 4 questions, I really want you to try it. And the one thing I like about math space is math space goes through step by step, and it also gives you hints. So hopefully it works for you, and I'd like feedback on that too. Any questions? I hope not. Anyway, join me on Thursday for a data dump of all this stuff. And take care. Have a great weekend.